a great time today because we have a phenomenal panel that we're going to be working with. So they will come up one by one. Can you guys give them applause as each one of them enters the stage? Okay, this is a test. Let's see if we can do it. So first up, we have Ariel Garten. She is co-founder of Muse NeuroTech for mental health. Let's give her a round of applause. Next up, we have Geoff, CEO, Sense Diagnostics, which does neurodetection. Geoff, come on up on the stage. Next up is Ryan Field. He is CEO and CTO of Kernel, which is about usability for all different types of medical professions. Come on up, Ryan. Next up, Bjoern Wolterman. He is CEO of Katalyst Neurostimulation, lives here in Las Vegas. And last but not least, can we do a drum roll for Tara Scudder, Anosmia Ambassador Ozricon. Thank you, guys. And I did break my femur, so I'm going to be hobbling a little bit here. So we'll see how we do.
I would say you're doing awesome.
I think I'm doing awesome too. I'm using this Katalyst suit too, so we'll hear about that Katalyst suit as well. So it's great to see you guys here. What I want to do first is I'd like to really talk a little bit about NeuroTech. You know, NeuroTech is at the intersection of technology and neurology. You'll notice I had no neurology in my background, but I had a lot of tech in my background. And technology is making such a phenomenal difference in this space. So what I'd like to do is to go around and talk to each of our panelists about why they founded or why they're running the companies they are today. And Ariel, I want to start with you first, because you've really been a trailblazer, really cool trailblazer, leveraging neurotech for mental health and mindfulness. And what I'd like to know is how you're helping individuals understand and improve their brain health.
Great, thank you very much.
Don't hold the bottom. Yep.
Hello? Wonderful. Awesome. Hey everybody, nice to meet you. My name is Ariel Garten, one of the founders of Muse, and yes, we've been trailblazers. We started out in 2014 with the first device in market, and since then have multiple different iterations of the Muse. Muse is a clinical grade EEG that tracks your brain in real time and gives you real-time feedback during activities like meditation, sleep, focus, etc. So we are a broad platform that other people build on top of to create applications in the neurotech space, as well as having our own applications that are now used by over 500,000 people. There are more than 500,000 Muses out in the wild. So we've been honored to really be able to make impact both in the individual users as well as in the clinical space. There are 200 papers published using Muse across long COVID, fibromyalgia, and multiple other conditions. And we also are very focused on deriving insights both from the individual and for the clinician using this tech.
I have to tell you, Ariel, because when we were prepping for the panel, my daughter overheard it and she goes, oh, can she really do things with my brain? She was fascinated with it. So I thought that was really cool. Geoff from Sense Diagnostics. You know, you guys are at the forefront of, can't very see you, there we go, neurodetection technology. So you're doing some really interesting things, and I would love to know how you are transforming how we detect and how we treat some of these neurological conditions.
Right. So there's a lot of advances these days in neurodetection because we know the earlier you detect it, the better chance of an outcome. You know, we ever have someone talk about, oh, they found that my mother has dementia, but good news, they found it early. Or, you know, my dad has brain tumor, but oh, it's too late, it really spread a lot. Everyone puts a time to that, but the early thing is so important right now to have better outcomes. At Sense, we focus on stroke and traumatic brain injury patients because when they suffer, you know, a stroke or a traumatic brain injury, you really have 1 hour to get that person from point of onset to treatment to have the best outcomes. But unfortunately, time to treatment on average for these people, it's about 6.5 hours. And there's so many different reasons that go into why there's such a delay. But for every hour you miss, their outcome probability goes down 10%. So at 6.5 hours, you've lost 65% of your chances of a good outcome. So for us, it's critical that we give technology out there that's available at point of onset to easily be put on the patient's head and turned on and have it immediately say, you know, they're suffering from a stroke, a large vessel blockage. They're suffering from a stroke, but it's a bleed. Because all that's really important information to get people to the right spot as quickly as possible for the right treatment. So that's what we focus on, and we're making tremendous advances on that.
You know, I'm so glad they're doing that because I've recently had my mother and my mother-in-law in certain situations like that. So this is really good, really hashtag tech for good as well as we're working through it. Ryan, so you have really been pushing, sorry, you're right there. I was like looking for you down there. You've really been pushing the bounds of brain measurement. You've got a portable NeuroTech solution, which I think is super cool. So tell us how you think this accessibility of that solution is going to influence what we're doing now and tomorrow.
Yeah, so Kernel was founded in 2016, and I've been there since 2018, helping develop technology and now leading the company through kind of the next phase here. And when we started, the question we were trying to answer is, can you build a more advanced type of brain measurement system that is also scalable and ready to, to be built and, in terms of tech readiness. And so we spent 5 years developing a new way to measure the brain from the ground up. And about a year and a half ago now, in 2023, we launched our second generation system that uses light to measure oxygen in the brain. So it's a fundamentally different way for measuring the brain than the other panelists here. But we think it's really unique and powerful because there's been so much academic work that's done that shows that technologies like fMRI can do really incredible things in terms of understanding brain state, brain function, and applying it to many diseases. So we've built a platform that can translate some of the findings from fMRI into real-world scenarios. So if I could say it very simply, yes, accessibility is kind of core to what we're doing, and we're trying to bring it into real-world clinical settings. So we have two sides to our business today. One side is very research-oriented. We work with academics and corporate partners who are doing research to understand either how the brain works or how their products interact with the brain. And then we have our own clinical development side where we're working to build tools that psychiatrists and neurologists can use to better treat depression and to better understand cognition in the cases of dementia. And so that's what we're really after here, is trying to bring clinical grade technology out into the world so that patients can benefit from all the advances that have been made in understanding the brain recently.
Oh, that's fascinating. Don't you want all these solutions right now? These are really, really amazing. So sitting beside me is Bjoern, and he's from Katalyst. Truth in advertising, I now use a Katalyst suit because with my injury, I can't work out as much as I used to. And you guys are really redefining neurostimulation. So how is that neurostimulation integrated into healthcare, and what potential do you see in personalized treatment plans?
So at Katalyst, we've built a full-body muscle stimulation suit that is consumer-ready. So it's not just applicable by a doctor or a trained physician who can actually use that, but we can actually ship it to end consumers. And we have basically 3 use cases. One of them is a performance use case, where people who are like athletes or special forces who really want to get the most out of it. The second group is people that generally don't have enough time to train. And the third group is people who have previous injuries or other ailments that bar them from traditional training methods. And if we think about it, we've been training for about 3,000 years in the same way. We've been lifting weights, we've been throwing things, we've been running for longer periods of time, but at the end of the day, the Olympic Games still look the same, plus pickleball now. But basically, we've been training for 3,000 years in the same way. But about 60 years ago, and this is where NeuroTech, some of this really started, we've been using muscle stimulation to train local areas of the body after an injury. And we took this technology and integrated it into a full body into a full body suit that now is usable depending on the use case. And to your question, what is the big difference here? It's the vast advancement in usability. So we have customers through all ages, through all ability groups, through all weight groups, through all types of injuries, types of activities that they're able to do, and we're able to take them to the next level of physical fitness without the downsides of traditional weight training, where you have external loads, where you have injury risks, where if you have like a knee replacement that's been happening, you can't just like lift and squat and so on and so forth. And we are all overcoming this because we can individually target each muscle group to train and improve the performance of each of them.
I kind of feel like Iron Woman in my suit, I have to say. And then Tara, I just met Tara, and she is a really incredible woman because she has something that I experienced during COVID, which I couldn't taste and I couldn't smell. But you have now a nonprofit that's centered around this particular, I wouldn't call it a disease. What is it? What do you call it? Condition?
You can call it a condition, yes.
Okay, a condition. So tell us about that. Like, how did you get started in this not-for-profit?
Thank you so much for the intro. Again, my name is Tara, and I am an anosmic. In case you don't know what that means I was born without the sense of smell. It's called congenital anosmia. And just by a show of hands, I was curious, how many of you experience what's called hyposmia, which is a reduced sense of smell? Did anybody get, like, during COVID perhaps, did anybody lose their sense of smell? And you see, I'd say, just to narrate for the audience, maybe about 30% of the audience just raised their hand. So the thing is for people like me, there are no assistive devices on the market other than a smoke detector. And that's simply not sufficient for what we need to navigate everyday life. So I was reading Wall Street Journal one day, and I read something that really intrigued me. Over at MIT, Dr. Andreas Merschen is his name. He was working on a smell detector device that would be paired with your cell phone, so the ultimate portability. So immediately, I reached out to him, and I'm like, thank you so much for all your work in this space, because it can make the difference for people like me and those suffering with smell loss due to COVID. So before I know it, I reached out, we became almost instant besties, invested in the same cause, and we put together Osmocosm over at MIT, which is an annual conference bringing together everybody in olfaction technology. And again, olfaction is the sense of smell. People don't realize this sense and that you could actually lose it until COVID happened. So together, we're bringing together researchers, artists, innovators, engineers, all to discuss the issues at hand, because there's a whole world out there that people like me haven't experienced. So,
thank you. Thanks, Tara. Now, how many of you were at Jensen's keynote last night? Yeah. And did you hear Gary? When Gary kicked it off, what did he say? He said, had I invested in this company when I first had him keynote here, I would be retired right now. Now, you guys are getting the inside scoop on all of these amazing companies because they are really transforming the way that we integrate health in. The opportunity here is really immense. So what I want to do now is really talk a little bit about the role that AI plays in what you're doing. And Ariel, I'm going to go back to you first again, and talk to me about how AI now plays a role. How does tech help you personalize that mental health solution?
Sure.
Differently?
So AI has really allowed us to gain new insights from brain data that we'd never be able to get before. We have probably one of the largest databases of brain data in the world, over 1 billion minutes of brain data. And from that, we've been able to create a large brain model. You've all heard of large language models, the methodology used by ChatGPT, et cetera. A large brain model allows you to create a model of what the brain looks like and then use small amounts of novel data to query that model to gain new insights. So one of the tangible uses of this, for example, is our sleep training algorithm. So with Muse, we have a device that is able to track your sleep as effectively as a sleep lab. So instead of going into a sleep lab, putting on cumbersome technology, and then having a sleep technologist hand score that data, in your own bed, you can wear your Muse device, and it will automatically in real time be able to detect the macro and micro architecture of sleep when you're in deep sleep, your sleep spindles, your K complexes, and do it more effectively than a sleep technologist would do it. So with AI, we've been able to better the understanding of the brain well beyond the existing experts. And we've done that in sleep. We're now doing it in multiple other domains. For example, we have a number of research studies running with individuals both with Alzheimer's and with familial Alzheimer's in their family, but not themselves showing signs, as well as gathering all of their blood and bio data. We're also gathering brain data with our research partners, and then being able to put that into our large brain model and identify what it looks like as the brain begins to have the onset of Alzheimer's, whether you can detect it yourself or not. We can start to see those changes in the brain. So AI has fundamentally helped us transform our ability to dissect and understand what goes on in the brain and then feed back personalized insights to you, both on a moment-by-moment basis as well as in a larger predictive model.
Interesting. You know what's funny to me is I did one of those sleep tests, and they put, have anybody done one? They put like 1,000 wires on you, and then they're like, just sleep normally. Like, how the heck can you sleep normally? So that is really cool. Is that the whole thing you have to wear?
This is it.
Wow, where were you when I had to do that test? That's incredible.
Well, now we're in market. Anyone can buy one and use it and give the data to your doctors.
So Tara, your not-for-profit has really put you in touch with a lot of the top innovators in the field. You just talked about one of those that you read about in the Wall Street Journal. What have you noticed about some of the common challenges that you face in this field?
Certainly. I've had the opportunity to speak with dozens in this space. Yes, there are dozens all around the world. And what I've learned is that it comes down to two things: a general lack of understanding and investment, and size. And by lack of understanding, I mean there are 400 receptor cells for the sense of smell, but there's only 2 for vision. So you can imagine how much easier it is to create devices and understand stuff for the sense of sight than it is for something like mine, anosmia. So there's so many, because actually when you smell what's called an odorant, it can trigger multiple receptors at the very same time. And so this fascinates me because the sense of smell seems multidimensional. It can light up different parts of your brain, and no two people can understand the scent the same way. They use different words, so there's so much that needs to be brought together to create these commonalities and these terms, and we're simply not there yet. And then when it comes to size, in the instance of food spoilage, for instance, just to detect food spoilage for one single item, the sensor was about the size of the palm of your hand 5 years ago. And now, it's about the size of a dime. So we're progressing, but again, that's just for one food item, like lemons being spoiled in your fridge, for instance. So if I want a remote where I could point it and know if my whole fridge was safe to eat, we are light years away from that, unfortunately. So together with the advent of technology, I hope that that can change.
Oh, that's fascinating. What good progress, though, in a small amount of time. So AI should be able to, hopefully, to accelerate that as well. Ryan, I'm going to go to you next, if I could. So with what you're doing, I know you're using AI to improve the accuracy and the usability of the tools, both for clinicians and researchers. So talk to us a little bit about that and the potential you see there.
Yeah, so we're really trying to tackle 2 different problems that we're building models around. So one is when a patient sees a psychiatrist, they may come in with symptoms of depression, and psychiatrists will tell us, we're pretty good at diagnosing, but what we really don't understand well is how to select treatment. So how do you pick from all the options that are available, which is the right treatment for this individual right now? And so what we've been doing is building up a data set that shows that we can, in fact, measure someone's brain and predict with over 90% accuracy if they will respond to treatment or not. And so this is, I think, a really powerful application of AI or machine learning in understanding what patterns of brain activity are representative of those that will respond well to treatment. And so this is one area that we have been spending a lot of energy and are seeing a lot of great progress on, and think it has a huge potential to really change the way that mental health is managed and treated. The other area is in cognition, which I think is something that all of us can kind of think about. I think it was mentioned earlier about how some of our parents maybe are aging, and that leads you to start seeing these symptoms and signs of decline. And so I think one of the questions that everyone has on their mind is, how can you detect it early? And then how can you do things to slow it or intervene? And so what we've been doing, we actually just last fall completed a study in mild cognitive impairment, again, showing very high prediction accuracy, or classification accuracy, I should say, in separating patients who have MCI or mild cognitive impairment, the early signs of dementia, from those who are healthy. And so recently what we've done is we've tried to take that back a bit farther and really focus on what the distribution of normal brain activity, normal cognition is over the lifespan. And so this gets back to this idea that if you want to monitor and improve something about yourself, you need to have good measures and understand what the expected ranges for those measures are. And so we're running that study right now. We're collecting the data and starting to build up the data set so that we can get to kind of a model that scores your cognition across all the different domains that are relevant for everyday life.
Interesting. Data is so important, and even here, right?
Yeah, I mean, it's hugely important, and I think, as Ariel said, like they have a billion hours and billion minutes of brain data, and that's an amazing size data set. And we'll get there. We have a unique technology, so it takes a little bit of energy and resources to build a data set over time, especially when it's not consumer ready. It's more of a clinical tool. So data is really important, and getting that data is, it can be challenging, but if you do it the right way, you can get really rich data sets that really enable you to build very accurate and useful models.
Interesting. Bjoern, how are you guys using AI, or are you using AI, I guess I should say? And talk to us a little bit about data as well, and are there any barriers to adoption that you see with your area of neurostimulation?
So let's start with the last. The challenge that we have is we are basically a too good to be true product. People have been told health and wellness and fitness can be easier, and no one actually delivered on it. And if we look at the history of technology in health and fitness, they're all motivators. Like, they're all trackers. They tell you how many steps you did. They tell you how many steps you should be doing. They might show you how to do a workout, and they have a DJ in the background that motivates you to do the exercise, but none of them are actually helping you in the process itself. You still have to run, you still have to lift, you still have to ride the bike, and so on and so forth. And I mean, what you're experiencing yourself is like, despite physical challenges, it still allows you to achieve goals, and it still allows you to strengthen your body. And this is one of the things that, especially in America, people almost don't believe exists after decades of unfulfilled promises, I would say. So this is probably an adoption. But the good news for us is, like, every customer is just can't stop talking about it and just tells all their friends. And that's just like a first thing that really works very well. In terms of AI, one of the things that we are using ML algorithms for is personalization, real-time personalization. So if you or I would do the same workout and would do the same exercises and whatsoever, like, our suit experiences are still very different, because over time our system is learning the capabilities of the body of each customer and each patient. So when, like, say both of us want to do a boxing workout, I would probably get a different challenge from the equipment than you would get. Or someone could say, like, I want to choose a different challenge level, or I want to focus on a different area of the body. All of that has to happen in real time. And I mean, real time is so fast that we have to do this on the edge, like on the device itself. So some things are even not coming even to the iOS device and go back. Some are even happening in hardware right away. And then some other things are happening on the iOS level. We don't actually have enough time to do the round trip to a server and coming back. So those are really interesting challenges. We're working on additional experiences that will use generative AI to device feedback, but this is something that I can't talk about yet.
Okay, secret. None of you guys
It's
will-
not
none
there
of you
yet.
guys
I'm
will
just
talk-
still writing all the IP, and that's a topic that otherwise I can't write IP anymore.
Yeah, that's true. Okay. It's interesting, though, because I do use this suit, and actually, you were working out in Sedona, I believe.
Some of our team did, yes. Yeah.
In Sedona, and they will say, I'm going to increase your intensity, and you can see them do it in Sedona, and your suit automatically goes up or down. It's pretty cool.
Yeah, the way we're doing this is the trainers don't only just record their image of what they are, basically instructing. They're also programming their own device, and we take this telemetry, we put it into the cloud, and then we stream it down to the customer. But instead of everybody gets the same thing, it gets customized and personalized in real time, and that's what we're using the tech for.
Very cool. Okay, Geoff, I didn't forget about you. I want to know also about some of the hurdles that you're coming into contact with around neuroimaging, and how is Sense Diagnostics really addressing some of those challenges?
Right, thank you. So, well, everybody knows the cost of healthcare is skyrocketing. That's a problem here in the United States and Canada and India and Africa, everywhere, a global issue. A lot of it driven by, just the cost of equipment is ridiculous. MRIs and CAT scans, all that stuff costs millions. And then the special technical skills that you need to operate that equipment. They do have new things coming out, like a mobile stroke unit, which I think is fabulous equipment, but it costs $1 million, and it costs $2 million a year to outfit it, to operate it. It's very expensive. So cost is a really big problem. The other big problem is access. And access, again, global problem, but especially out in the more rural areas where you've had a lot of hospital closures or you have no advanced imaging whatsoever available to treat patients. That's a huge problem. And so what we're doing about it with the equipment that we're developing, we knew within our critical to quality, it had to be, obviously very accurate technology and all of that, but we had to be very low cost, but we had to be very effective, and we had to be very easy to use. It had to be so easy that all they had to do is put it on the patient's head and turn it on, and it's going to give them an answer. So, and we do a device for the military. They said, make it easy enough that an 18-year-old who may or may not have a high school education can put this on somebody's head in the front lines and see whether they're hurt or not. So easy technology to use, but very accurate in what it does. So, those CAT scans and everything else that cost millions of dollars, then the mobile stroke unit is, so expensive. Our technology, our control unit is about the size of my fist, and that costs $5,000, one-time cost, and then we use disposable headsets that cost $200. So you could spend $1 million on a mobile stroke unit, but you can get our kind of equipment, which is going to immediately detect the issue with that patient, and then, as I say, get them onto the right place at the right time for treatment.
Yeah, so very quickly reacting to what you're saying, like usability is one of the aspects that in general come last, and people don't really think about it. They think, is it technically possible? Does it technically work? And so on and so forth. But how do you make it really so easy to use that's mass adoptable? That's such an important thing in our area, because otherwise, yes, we have things that theoretically work, but they're not really truly accessible. And the second thing is cost, like the same for us. So the technology, when I discovered it, was like $30,000 a unit, and it wasn't really like, you needed a long time to figure it out. They were very analog. There was no learning in there. Nothing really worked. And at this point in time, it's I can just literally give it, I send it to someone at home, and they open the box and they connect it to their iPhone, and then it walks them through how to do it. And My grandma can do it on her own, and she's non-technical. So, like, for real mass adoption of technology, we all have to look at how do we not only make it function and work, but how do we make it economically feasible, and how do we make it usable?
Interesting, yeah. I think those are two of the really big things for any emerging tech is how do you make it usable, how do you make it cost effective, and how do you make sure it works? I think if you can do those three things, you have a winner. Okay, so we're down to 10 minutes, believe it or not. But I still want to go through, I still have 2 more questions for you guys, if we can squeeze it in, and I promise we won't go over. But one of the things I want to know is if you guys looked out 5 years, and in your area, you could tell this audience, here's one thing that I think is going to happen that is a total game changer. What would that be? And I'm going to ask this to everybody. So actually, Ryan, I'm going to start with you this time. So total game changer. You only get one thing, not 2, not 3, one thing. What do you think is going to be a total game changer in your area?
Yeah, so for me, I think it's most likely to be that psychiatrists will now have a tool to use to understand the condition of their patient before they write a prescription. And I think this is completely game-changing from where we are today, where it's a lot of trial and error and long times to actually achieve successful treatments. So I'm really excited and believe that measurement data can help to inform better treatment decisions. And to the point about building usability and access into everything, also credibility. And so like this idea that we have technology that is still in this state of being kind of unbelievable to most. And so I think it's about building the evidence to make believers out of people that you can actually use this tech to solve real problems for people.
That's a great point. And also economic, right, what you talked about. So if I know the treatment's going to work before I do it, then I don't have to do like 3 or 4 treatments and waste money too. That's pretty awesome.
Yeah, and some of these treatments can cost tens of thousands of dollars, so very expensive treatments to fail.
Yeah, absolutely. Okay, what do you think, Ariel?
So I think in 5 years, we're going to have technology that can not only track your brain health, but give you interventions to improve your brain health. And that's going to be a massive game changer for all of us. It's something that already exists now. With Muse, you can do meditation interventions, you can improve your sleep, you can do a range of things to improve your brain health, and you can track your brain health, tracking things like your alpha peak frequency, your ERPs. So, this is just the beginning of the revolution of having brain health in your own hands, on your own head, pun intended. Is there a pun there? I don't know. To be able to really track and improve and be able to stave off age-related cognitive decline.
Very interesting. And do you think that's possible in the next 5 years?
As I said, we're doing much of it now. So the next 5 years is about the rollout of it, the further validation of it, and just continuing to quickly and rapidly improve the technology and the tools.
Okay. 5 years, Bjoern. What do you think? 5 years. What do you think is the biggest improvement?
I think in 5 years we've solved sarcopenia, which is the age-related loss of muscle mass, and obesity in the United States. And for 2 reasons.
Give that a big round of applause, right?
No, like I truly believe it. I truly believe it. And here's the reason for that is with all the discussions around GLP-1 antagonists or agonists, which basically a neurological intervention, which like improves your ability to stick to a plan at the end of the day. It increases your ability to have self-discipline. We're gonna get into a place, and we're just doing a study with the Mayo Clinic where we are combining weight loss medications with the buildup of muscle mass. In terms of like muscle stimulation, and it is one of like the most exciting study that we've been doing in a long period of time, and because we're going to get the cost down of what we have and the patents run out on other things, so I think from a mass accessibility of a healthy body composition by 2030, it's going to be normal. I think it's going to be as normal as we have electric toothbrush now, where like, in the early days, like who had an electric toothbrush, and today we buy them at Costco. So I think we're going to have a mass prevalation of these technologies, and when you walk down the street, America will look different.
That's pretty amazing. I like that. I like that one. Okay, Geoff.
I love this question because when you go to the doctor today for a checkup, what's the first thing they do? Aside from make you stand on a scale. We'll ignore that piece. They bring you in and they check your vital signs, right? So they check your lungs, they check your heart, they check your blood pressure, pulse oximeter, reflexes, all that stuff. When they're done, what's the one thing they didn't check? They didn't check your brain. And what's the most important part of your body? Probably your brain. So, but what we see, our vision in 5 years from now, is that in a healthcare facility, at a doctor's office, they have a device which they put on your head and just simply turn it on. And that device will be able to detect the early presence of any abnormal tissue that may be developing in your brain, be it tau proteins, be it early presence of metastatic cancer cells, any of that. But that's what we see, that there is a device that could be able to detect all of that. And we know we could do it because right now we have the basis for that because we could see ischemic tissue and we could see blood. We just got more research, more development to be able to see the different markers of those other conditions, add that into the algorithm. So that's what I see.
I like that, the brain. And you think that is doable in 5 years?
I hope so, yeah.
I hope so too.
Yeah.
Hope you guys do it for sure. Okay, Tara, what do you think?
I'm so excited about the future, everybody, because NeuroTech is the answer to solve anosmia, hyposmia. The thing I'm really excited about is the use of EEGs. When people are exposed to an odorant, you can see different areas of the brain light up. And so by understanding the emotions and how smell is actually processed in the brain, we are able to create change in this area by understanding it more. And I'm very excited about PlayStation. And for example, they filed a patent where it's an ultrasound device that would be, ultrasound wave that would be beamed into the user's brain. Look it up. And so once we know that you can trigger a certain scent by accessing a wave on the specific part of the brain, that is going to be amazing because everybody pays attention to what PlayStation does. It goes in millions of homes. So there's definitely a lot of potential in this area.
Awesome. Okay, we have 2 minutes left, only 2 minutes left, but I want to give these amazing leaders, aren't they awesome? Can you guys just give them a big round of applause for what they're doing? I want you quickly, so remember, we only have 2 minutes, and she said she's going to hit me with my cane if I run over. So just remember that. Oh, yeah, hide it. Okay, there you go. So give me one thing you want everybody in this audience to take away, and how can they experience what you've talked about? So we'll start with you, and we'll just go straight down.
So the takeaway for me really is there's more, there's really more out there. And if you have a challenge, most likely technology exists, is early, reach out to a company and try to work with them. We, for example, always are looking for people that want to prove that certain things work for them and that they can improve parts of their lives. If you want to experience Katalyst, go to katalyst.com, sign up. We have events all over the country where people can try things and test things. Just reach out to us, and yeah.
I can vouch it's fun, too. I like the boxing one. I do. Okay, Ryan.
I guess my takeaway would be measuring the brain is really hard. It takes a lot of patience and a lot of data, but sticking with it, I think there's a big payout, big reward at the other end. And if you want to experience any of Kernel technology, we have a couple of ongoing studies, so things listed on clinicaltrials.gov you can find, and we have a healthy volunteer study running in LA now. And then if you are interested, if you have a problem you're trying to solve and want to explore a research project, reach out and we'll be happy to discuss.
My takeaway would be that measuring the brain can be quite easy. You can do it in your own home right now. If you want to learn more, you can go to choosemuse.com, CHOOSEMUSE.com. You're welcome to reach out to me personally as well, Ariel at choosemuse.com, and we're open for a wide variety of partnerships. We work with researchers, pharma, developers building their own apps on top of Muse, as well as individuals just using it for their own practices. So happy to chat with everyone.
I want one of those for sure. Geoff?
My takeaway is, look, there's a lot of advances being made in neurotechnology. For years, the money's been invested in oncology and cardiac care and all of that. We're really sitting on the cusp of being able to deliver tremendous technology into the market for the brain. And that's what we as a company are focused on. And, you know, we think we're at the cusp of greatness, really.
Yep, I agree. Tara, bring us home.
With 1 in 8 people experiencing some form of smell loss, I encourage you to invest your time, energy, and wisdom into this space because smell matters. And if you need somebody that doesn't have a sense of smell, we're kind of rare. We're only 3% of the population. So reach out to me. I'll help what I can.
Awesome. Okay, can I ask the audience one thing, one favor now? You guys each probably took away one thing at least, right? Correct? Correct? Yes? Okay, can I ask you guys to take a picture of this panel and post one thing on social media? Tag CES, take a picture of the panel and post one insight that you had, because now you guys will all be retired next year, right? From all the great insight. Thank you guys very much. Really appreciate it. Thank you to the audience.